Right, so if we take this chart is on electronegativity. And electronegativity talks about how much an element tends to pull electrons closer to it. So the higher the number, the more electronegative it is. So if we look at this chart, the most electronegative atom is F, which is fluorine. That means that fluorine really pulls electrons very close. If we look at the opposite side, the least electronegative is the cesium. That means that the cesium does not pull very hard. Right, so we have two opposites. Look at why they are opposite. To start with, fluorine has 7 electrons in the outer shell, so it only has to get one to get stable. If it only has 2 shells, with 2 in the first and 7 in the second, that nucleus sitting right there is able to attract those negative electrons easily. If we compare it to the iodine, down there, that iodine has 1, 2, 3, 4, 5 shells. It also has 7 in the outer shell. So even though it only has to get one, look at how far away that nucleus is. So it is difficult for that nucleus to attract electrons. Take the opposite side, we have cesium. It has 7 shells. I take it back, it has 6. 6 shells with 1 electron in that outer shell. That nucleus is so buried under all those shells that it is difficult for it to hang on, so it is easy to get rid of it. And it is also difficult for the nucleus to attract anything. So electronegativity talks about the attraction. How much can an atom pull electrons in? All right, so let's take an example. Let's take this bond. We're going to have lithium. Whoops. We're going to have lithium bond with fluorine. Right, now this is going to be an ionic bond. How do we know? Because lithium sits over here, and the fluorine sits over here. So anytime we have a metal and a non-metal, it will form an ionic bond. That means lithium gives up electrons to the fluorine. So we've got a complete transfer. That's because the F attracts those electrons very strongly. The lithium doesn't attract them as well, so it's easier for it to give it up. But we can also use our chart. If we look at this chart, we had lithium, which had a number value of 1. And we had fluorine that had a value of 4. Right, look at that difference. The difference between 1 and 4 is 3. If I look at this chart, anything that has a difference greater than 2 is going to be ionic. If that difference is less than 2, it will be some type of covalent. It could be nonpolar, it could be moderately polar, or it could be very polar. In fact, these compounds are just about ionic, but they don't get that complete transfer. All right, so let's back up again. let's take this compound. We will take oxygen, and we will take sulfur. All right, in order for those two to be stable, since they both have 6 in the outer shell, they're going to have to share 2 pairs. That means we have a double bond. Right, the difference between them, 3.5 and 2.5, is 1. So if I look at this, a difference of 1 means it is very polar. Alright, so I'm going to go back. So this will be a very polar compound. Doesn't want to write. So very polar, that means that we're going to get that partial positive and partial negative. So look at the numbers. Which one has a stronger pull? If you said oxygen, you are correct. So oxygen tends to pull the electrons closer to it. That gives the oxygen a partial negative charge. That leaves the sulfur as a partial positive. We say that these are partial charges because the oxygen doesn't completely take it. If it completely took the electrons, that would make it ionic. But these electrons are still being shared. It's just that the oxygen is able to pull those electrons closer to it. All right, let's check out a second example. Let's take an oxygen and bond it with itself. Let's get rid of this. Alright, so we'll take an oxygen and bond it with itself. So oxygen is in the 6th family. That means it has 6 electrons in the outer shell. It has to gain 2. The second oxygen, same. Whoops. Let me get rid of that. Right, so to get stable, they each have to share 2 pairs. Now we've got 2, 4, 6, 8 around that first oxygen. The second oxygen has 2, 4, 6, 8. So each oxygen is stable. Check out the difference. They both have a value of 3.5. That difference will be 0. If I check my chart, if I have a difference of 0 to 0.4, that means I have a nonpolar covalent. Right? If it is nonpolar, that means that these are being pulled equally, but in opposite directions. So if it is equal and opposite, they cancel each other out, and I don't get any partial negative, and I don't get any partial positive.